So now we'll discuss the OSPF virtual links. So we already know that the OSPF is a link state routing protocol. It sends the LSA, the link state advertisements, the multicast updates. It sends to the address 224.0.0.5, this address. And definitely every router has the information or link states about the others. But what is the use of the virtual link? Let's explore. So OpenShorted first is a link state routing protocol that facilitates the efficient routing within IP networks. We already know that it has a robust mechanism of disseminating the routing updates. It sends routing updates to its peers, the neighbor routers, and it allows routers to share information about the state of the links, and it enables them to make optimal routing decision. So inside an autonomous system, it makes the decision of this routing. But let's say there is a special area that is known as the backbone area. There is the area 0. And without the area 0, can we send the routing updates? No. And there is a concept that is every area or every interface of the router rather should be connected to area 0 in order to disseminate the routing updates. If it is not like that, then definitely your routing updates will not flow. Now, what is a virtual link? A virtual link in OSPF serves as a logical connection, enables OSPF routers to interact across non-contiguous areas. Now, what is a non-contiguous area? Non-contiguous area means that there is an area 0, area 1, area 2, all are connected serially. But say area 0 is connected to area 1, but the area 2 is not connected to area 0. If that case is there, that is a non-contiguous area. So from area 2, you cannot say the routing update will flow to the area 0 because there is the area 1 that is between, and definitely there is a problem that the area 2 doesn't have the direct connection to the area 0. So that is the discontiguous network. This function is crucial for linking discontiguous OSPF areas and ensuring effective routing and communication. So if you're having different areas and you're having the discontiguous areas, then definitely you should have the virtual link. Now, what is the purpose of virtual link? First is connect discontiguous areas that we have already discussed. Virtual links play a crucial role in connecting discontiguous OSPF areas, and it enables routers in separate areas to communicate effectively. So if you are having, say, in one enterprise you are having area 0 and area 1, other enterprise you are having totally the other area like the area 2 or like that. So definitely you should go for this virtual link concept. Then maintain OSPF area hierarchy. So by allowing the non-contiguous areas to link together, the virtual links help maintain the hierarchical structure of OSPF areas. Like within an autonomous system, you have the area 0 or backbone area on the top, and you have the other areas inside that. So definitely you can have the structure, and it ensures that routing information is properly disseminated across the areas. And it facilitates the communication between remote areas. So virtual links facilitate communication between the remote areas that are not directly connected to the backbone area. So this capability allows for more flexible routing, means that if some area is not directly connected to area 0, definitely that will be suboptimal routing. So in order to prevent that, you can have this area that is one area that is connected to the other area, that is the area 0, with the help of the virtual link. Now, in view of that, what are the OSPF network types that we see? We have the point-to-point connection, that is a P2P network. We have broadcast network type, non-broadcast multi-access, and point-to-multi-point structure. So you have different network types, and definitely the hello and dead timers will be different in each of the network types. But virtual link is required in each of the network types. That is definitely there. So that is about the theoretical discussion about the OSPF virtual link. But now we should definitely see it in practice. So let me take you to the GNC console here. We have the three routers running. So we'll configure R1, that is one loopback will be there. Say 10.0 will be in pure area 0. And passing the 0 by 0, you will have on the network like 192.168.0 running. In R2, you have area 1 and area 2. So on area 1, you have 192.168.0, and on area 2, you have 192.168.1.0, and on R3 also in the area 2, 192.168.1.0. So we'll configure these areas quickly now. So let's go to the R1, with pack 0, the address say 10.0.0.1, 0 by 0, and no shirt. IP address is 192.168.0.1. 192.168.0.2. Interface F0 by 1, or rather, I think this is, yes, F1 by 0. Here is 192.168.1.1. Interface 0 by 0 is 192.168.1.2. And now just configure the OSPF, say router OSPF 1, and the network is 10.0.0.55.255.255. It should be in area 0. The network 192.168.0.0.0.0.0.0.0.0.5 area, and then the area 1, then the area on the router 2, 1, network would be 192.168.0.0, area 1, and network 192.168.1.0, 2, and R3 also 192.168.1.0, area. So we have configured the OSPF. You can see that on R1, if I go here and use show IP OSPF database, you will see all the database related informations, and also yes, the OSPF route is loaded, it is done. You can see the type 1, the summary net link, type 2 LSA, all these things you can see. You can also go to the R3, show IP OSPF database. You can see that it has come with the, it is showing you the 1.2. This is router, but this area 2 is not connected to area 0. So this is a discontiguous area, this one. So we should create a virtual link between R1 and R2, that is the ABR. So let's go to the R1, config T, router OSPF 1, and you give area 1, because area 1 is connected to area 0 here, area 1, and then the virtual link, then give question mark, that is the IP address associated with virtual link neighbor. What is the neighbor? The neighbor is R2, and R2's which address? This type of address, F1 by 0, that is 192.168.1.0. 1.1. So let's go to the R1. Virtual link is 192.168.1. So that is one side. And on R2, you create a virtual link with R1, say the loopback. So we created a loopback interface here, that is 10.0.0, because the virtual link is created to the router ID, that is the highest IP address. That is why. So go to the R2, we are in router OSPF 1. So you create again area 1 and then virtual link with the R1, so the loopback, that is 10.0.0.1. This address, so we'll verify that the address is indeed the 10.0.0.1 that we created, and virtual link is already established. So you can see that it's 10.0.0.1 back. So if you do that, and you can see that the OSPF virtual link has come up, and also on the R2. And if I see here show IP OSPF, then virtual link, you'll see that the virtual link to router 10.0.0.1 is up, and you can see all the details of the virtual link on R2. Also on the R1, show IP OSPF virtual links, you'll see that virtual link to 192.1.1 is up. And here if I see show IP root, you'll see the OSPF inter-area root now, that is the 1.0. Also on the R2, show IP root OSPF, you can see the OSPF root. And also if you go to the show IP OSPF database, you can also see the OSPF database here. So everything you can see here, you can see the virtual link that is established between the two ABRs, R1 and the R2. So between the R1 and the R2, you have the virtual link established. So this is about the OSPF virtual link, and I'll see you in the next chapter.